Hello everyone. Today I am going to talk about Kohlrausch law of independent migration of ions. We have already learned that molar conductivity lambda m of electrolytes increases with dilution till a limiting value lambda m infinity is obtained at infinite dilution. Kohlrausch studied lambda m infinity values of various pairs of strong electrolytes. Here the table gives the values of molar conductance at infinite dilution for some pairs of electrolyte having the common ions. To study the difference in molar conductance at infinite dilution for each pair give rise to some interesting facts. Now in this table there are the two sets. In a one set, this is set second. In first set, what happened here the anions is common here. Cations are the different, anions are same. Okay. First pair is that the example is a potassium chloride and sodium chloride. In this, Cl minus is a common here, but the cations are the different here. In second pair, the nitrate ions are same, common, and the potassium and sodium are the two cations are the different here. In the third pair, hydroxide ions is a common anion and the cations are the different. And its molar conductance at infinite dilutions values are given. Lambda m infinity is given. For the electrolyte KCl, the lambda m infinity value is 0.0150, and for sodium chloride, the value is 0.0127. Then another example is the lambda m infinity value for potassium nitrate is 0.0145, and for sodium nitrate is 0.0122 Siemens meter square per mole. In the third pair, the lambda m infinity value for potassium hydroxide is 0.0271 Siemens meter square per mole, and for sodium hydroxide is 0.0248 Siemens meter square per mole. And next, the difference of the pairs. Okay, in the first example, the difference between the two electrolytes is 0.0023. In second pair, the difference between the lambda m infinity values is 0.0023. In the third pair, the lambda m infinity, the difference is that 0.0023. We observe that the difference is a constant. The difference is constant 0.0023. In set second, here the cations are same. Cations is common, but anions are different. Okay. The first pair is that potassium chloride and potassium nitrate. Here the K plus is a common. Okay. Anions are different. And in second pair, the example is sodium chloride and sodium nitrate. Here the cations are common, the anions are different. In the third pair, the example is hydrochloric acid and nitric acid. Here the H plus are common, that is cations are same and anions are different. In the first pair, the lambda m infinity value is for potassium chloride is 0.0150. 0.0150 Siemens meter square per mole, and for potassium nitrate the value is 0.0145 Siemens meter square per mole. In second pair, the lambda m infinity value for sodium chloride is 0.0127 Siemens meter square per mole, and for sodium nitrate is 0.0122 Siemens meter square per mole. In third pair, uh, the lambda m infinity value for hydrochloric acid is 0.0426 Siemens meter square per mole, and for nitric acid is 0.0421. And again, we take the difference of these pairs. Okay, difference of lambda m infinity values is again the constant, that is a point not 5. Here again the point not 5, point not 5. Again this difference is a constant. This difference is constant. It is observed that the difference between the lambda m infinity values for the pairs in set 1 and set 2 are constant. Lambda m infinity is a sum of arising due to the cations and the anions. Set 1 has common anions, so that difference can only be due to the difference in contribution to lambda m infinity by k plus and Na plus ions. Set 1 has common anions, so that the difference can only be due to the difference in contribution to lambda n infinity by k plus and Na plus ions. In set second has common cations. In set second has common cations, so the difference can only be due to the difference in the contribution to the lambda m infinity by chloride ions and 3 minus ions. Now, what is the statement of the Kohlrausch law? The statement is that when all the forces of interaction between the ions disappear, when all the forces of interaction between the ions disappear, when the dilution is increases, when the dilution is increases, there is no attractive force and repulsive force is possible between the ions. When all the forces of interaction between the ions is disappear, each ion is migrate independently of its co-ion. Each ion migrate independently of its co-ion and makes a definite contribution to the total molar conductance of the electrolyte and makes a definite contribution to the total molar conductance of the electrolyte, and this contribution is independent of the nature of the other ion. This contribution is independent of the nature of the other ions with which it is associated in the electrolyte, with which it is associated in the electrolyte. For example, when the dilution means volume is increases, you can take the example of the sodium chloride, potassium chloride. These ions, this electrolyte is add in water, so that the ions can be formation. That is a you can take the example of potassium chloride, K and Cl. You can take the cation, its co-ion is a chloride ion, and you can take the ion, suppose Cl, its co-ion is a K plus. Okay. Uh, on the basis of this conclusion, the Kohlrausch put forward the law of independent migration of ions in mathematical form. It states that the value of molar conductance of an electrolyte at infinite dilution is equal to the sum of the conductance of the constituent ions at infinite dilution. Again, it states that the value of molar conductance of an electrolyte at infinite dilution is lambda m is equal to the sum of the contribution, the sum of the conductance of the constituent ions, sum of the conductance of the constituent ions at infinite dilution. This implies that the molar conductivity of an electrolyte at infinite dilution can be expressed as the sum of the contribution of the cations and anions. This implies that molar conductivity of an electrolyte at infinite dilution can be expressed as the sum of the contribution of the cations and anions if lambda plus infinity and lambda minus infinity are the molar conductivity of the cations and the anions are respectively. If lambda plus infinity and lambda minus infinity are the molar conductivity of the cations and anions are respectively at infinite dilution, the molar conductivity of an electrolyte at infinite dilution lambda m infinity is given by the molar conductivity of an electrolyte at infinite dilution lambda m infinity is given by. Therefore, lambda m infinity is equal to the V plus lambda plus infinity plus V minus lambda minus infinity. Here again lambda m infinity is equal to the V plus lambda plus infinity plus V minus lambda minus infinity. Here V plus and V minus are the number of cations and anions. V plus and V minus are the number of cations and anions produced by each formula unit of the electrolyte. Therefore, for example, sodium chloride. Sodium chloride can be ionized as Na plus Cl minus. Okay, therefore the lambda m infinity of sodium chloride is equal to the lambda Na plus. They are the two ions are formed. One is the cations Na plus sodium positive and another is a chloride negative. Therefore, we take the lambda, okay, molar conductance lambda Na positive infinity plus lambda Cl minus infinity. Lambda Na plus infinity plus lambda Cl minus infinity. Here V plus number of ions. Say Na plus is equal to 1. Okay, that is V plus is equal to 1 and V minus is equal to the 1. Okay. Now another example, barium chloride. Okay, here the Ba is dissociated as Ba2 plus 2Cl minus. Here the 2 moles of Cl minus. That means here the we take the molar conductance and infinite dilution of barium chloride salt. Okay, is equal to the molar conductance of the cations. That is beryllium 2 plus. Okay, infinity plus 2Cl minus. Here the V. What is the value of P minus? That is a 2Cl minus. That is V minus equal to 2. That is a here the V minus. That is a substitute here the 2. 2 lambda Cl minus infinity. Lambda Cl minus infinity. Okay. Another you can take the example of the acetic acid. So as it's dissociated as acetate ions plus H plus. That is V plus is equal to 1 and V minus is equal to the 1. Okay. Now the next point is that the application of conductance measurement. Applications of conductance measurement. The first application is that the degree of determination of degree of ionization. Determination of degree of ionization. What is the degree of ionization? The symbol is alpha. Degree of ionization is represented by the symbol alpha. The degree of ionization is the fraction of